Okay, so now we're going to do some practice examples with our angle relations. These are just some problems that you're going to come across. It's just a small sampling. The first thing we're going to do is solve for x. I know that angle A and angle B are complementary. Angle A, the measure of angle A is 2x minus 8, and the measure of angle B is 6x plus 2. So I've got to remember, what does this word complementary mean? Right, 90 degrees. So that means when I add angle A and angle B together, they will equal 90 degrees. So let's set that up. Let me double check. 2x minus 8 plus 6x plus 2 equals 90. I'm going to see how my best friend is doing this morning. And let's see here. 2x minus 8 plus 6x plus 2 equals 90. All right, I got to adjust my zoom. X is 12. Have I solved the problem? I don't know. What am I looking for? I'm solving for x. So yeah, I'm done with this problem. I didn't have to do any kind of substitution because right up here it says solve for x. Cool, that was pretty easy. Could I have found the measure of angle A? Yeah. I would have said 2 times 12 minus 8. Let's do it just for the fun of it. You might have some problems where you have to substitute those values in. I get 16. So the measure, I don't need to put that in. I'm just going to say angle A equals 16 degrees. And B would have been 6 times 12 plus 2. So 6, 12, 74. Angle B would equal 74. So it's pretty easy. You're just setting these things up, typing them into Desmos, and then making sure you're answering the question the way it needs to be answered. So if complementary was 90 degrees, what's supplementary? Let's do this one in a different color. Supplementary. Right, supplementary was the 180. So angle C and angle B are supplementary. The measure of angle C equals 4x plus 11, and the measure of angle D equals x plus 4. So now I'm going to say 4x plus 11 plus the other, I got a typo. Because this says B and this says D. I bet you this is a typo. This is my typo. I'm going to change that to a D. Sorry, guys. All right. 4x plus 11 plus x plus 4 equals 180. Get my Desi out. That's what I've nicknamed my Desmos calculator, is Little Desi. I think he likes to be called that. All right, 4x plus 11 plus x plus 4 equals 180. Again, let's fix our zoom. Click on it. 33. X is 33. Now, same thing. All I had to do was solve for x, but let me show you how you would take your answer and find out what the actual angle measures are. So C was 4 times x plus 11. So 4 143. So angle C is 143 degrees. And D is just simply 33 plus 4. 37. So angle D equals 37 degrees. Now, what could I do to double check myself? Any ideas? Yeah, I want to stop and make sure that I typed it into the calculator correctly. But if I know that angle C and angle D are supplementary, and I know the values of those angles, what could I do with those two angles to double check? Yes, you most definitely could. I would take 143 degrees and I would add it to 37. And it should equal 180 by definition because those two are supplementary. Same thing as I can do with angle A and B. I could have made sure that 16 plus 74, let's do that now. 16 plus 74, yes, that equals 90. So you could take that, what was that, 30 seconds maybe? You could take that quick 30 seconds and double check yourself to make sure that you've gotten the correct answers. All right, we got some more examples. For this example 1, I need to find x. Oh my gosh, how am I going to do that? Well, I've got this 125 degrees. Is there a relationship between x and that 125? Yeah, there should be. So let's see. Here's x, and here's 125. What is that? Right, vertical angles. So if you look at your problem and you identify what kind of relationship that has with the information you're given, that's going to help you figure these problems out pretty quick. So in example 1, x equals 125 degrees. Now, some of these little degree marks have been left off simply because that's really hard to get your software and your computers and stuff to put that degrees in there. So I won't count it wrong if you don't have it there, because I understand that if you're typing an answer, sometimes you just can't do it. However, double check with IXL and see if there's a button or something, or sometimes they have it preset for that degree mark to show up. All right, example 2, I got to find x and y. Well, you could go about this one a couple of different ways. When I look at this, I can spot that this 86 and that y, that 86 and y are vertical angles. So right off the bat, I'm going to say y equals 86. The other thing that I notice is that x and 86, they appear to be on a straight line. And so if there's two angles that are adjacent and it's a straight line, what else can we say? Right, those would be supplementary. So if I said x plus 86 supplementary angles would equal 180. Yeah, you could have just simply said, and that's what some of you were probably thinking right off your head, why don't you just say 180 subtract 86? Yes, you can. That's not a problem. It's just you're looking at it a different way than I did. Okay, example 3, find x. And then beneath it says, assume the left angle is a right angle. Well, first of all, when we've got this little square right there, that indicates it is a right angle. And I don't know how much you remember about right angles, but if you've got a right angle on one side, then on the other side, that's also a right angle. What does a right angle equal? Like what are the degrees? 90. So right angle equals 90 degrees. Okay? What can I do with that 90 degrees? I got to do something with it. I got two adjacents here, and when I add them together, they make a right angle. So when I add these two angles together, if they make a right angle, then those two added together will equal 90 degrees. You got it. You guys are doing such a good job. Now, let me double check myself. 3x plus 15 plus 2x equals 90. Yep, x equals 15. All right, the fourth problem. Wow, I don't have a number. What am I going to do? Oh my gosh, don't panic. It's all okay. Look for vertical angles. This is a vertical angle with this one down here. See that? Vertical angles are what to each other? Oh, let's go with purple. Right, they're equal to each other. So if two things are equal to each other, what do? We will say 2x plus 28 equals 3x minus 14. Desi comes along to save the day. 2x plus 28 equals 3x minus 14. All right, change my zoom. Click on it. X equals 42. So now what do I got to do? How am I going to find y? Right, substitute. So it doesn't matter which angle you want to find because they're the same size. I'm just going to go with the 2 times 42 plus 28 because for whatever reason I feel like it's easier to multiply and add than to subtract something. So that angle is going to be 112. So if 2x plus 28 is 112, 3x minus 14 is also 112 because vertical angles are congruent. All right, if I know that I've got an angle that's 112, and I'm pretty sure it's sitting on a straight line. That's a straight line, right? Well, maybe the one I draw wasn't very straight, but that's a straight line. Right, then you would say y plus 112 equals 180. So again, it's just going to be 180 subtract 112, and I get y is 68. So that wasn't so bad. It seemed a little scary because you didn't have anything at first jumping out at you, but it's not so bad. So one thing that we didn't talk about in the other video was perpendicular lines. When lines are perpendicular, they form a 90-degree angle. And the square in the figure indicates that the lines are perpendicular. And the symbol that we use for perpendicular is an upside down T. And you would read that whenever you see that symbol, you want to replace it with the expression is perpendicular to. And then again, I just want to reiterate that if you've got a right angle, then all the way around, you're going to have right angles. That should probably be some review from either Math 8 or Algebra 1. And we'll do one problem. So this is how this sentence would read right here. If AD is perpendicular to CB and the measure of angle CED equals 2x minus 6, then find the value of x. E is the point of intersection. Wow, what does that mean? All right, well, AD and CB, that sounds like I got two segments, and it sounds like they're perpendicular, which means I got to make these intersections look like I got a right angle. See if I can draw that line a little bit better. All right. A, D, C, B. E is the point of intersection, so that'll be E. I've got an angle CED, so CED is right here. Talking about this angle, I'm talking about this part over here that's highlighted. That angle is 2x minus 6. And I also know that if those two segments are perpendicular, I got a right angle. How many degrees is a right angle? Yeah, 90 degrees is right angle. So 2x minus 6 equals 90. Not so bad. Super easy after I drew my picture. So when you don't have a picture, you really should be drawing one. Sometimes after you draw the picture, you can almost figure out the problem in your head without much work. So x is 48. So I hope that you're starting to see that you've got about 4 basic equations in geometry, okay? So this first one, so inside the parentheses is some x's and y's or whatever variable we're using with. Sometimes it's the two angles that we're talking about. But in this first setup, something equals something. All right, we're going to have words like congruent, congruent angles, congruent segments. And today we've seen that vertical angles are congruent. So you'll learn that you're either going to set things equal to each other, or I'm going to skip down to the 90 and 80. Things are complementary. Things are supplementary. Or sometimes it might be on a straight line. All right? Now, this one right here, that's what we use when we had like the two smaller segments equaled the whole segment. Or it was when we had two smaller angles, the two smaller adjacent angles equaled that bigger angles. So this is almost like small equals the big one. Okay, so those are our 4 basic equations that we're just going to keep going back to over and over and over. And when you get stuck on a problem, you're probably going to hear me ask you, okay, are they congruent to something? Do you got vertical angles, vertical segments, like congruent segments? Like, you won't have vertical segments. I don't know why I said that. But I'm going to say, what is it equal to? It's equal to something. Set it equal to that and then solve. Or I might say, well, what do you have here? 2 small pieces and a big piece? Like, put the 2 small pieces together, you get the big piece. Or I might say, well, what do you know about your angle? Is it complementary? Is it supplementary? Are you on a straight line? Like, what are some things? Like, there's just a few basic things that we're going to set stuff equal to But we're going to do that for the whole time we're in geometry, okay? The whole time. So we're done with this little mini lesson.